Hello, it's a great day for math. So now in this graph question, I think part A and B is pretty straightforward. Fill up the table and draw the graph. So in a moment, I'll just fast forward this and show you the end product of A and B. There you go. So that is the completed table and the graph with a labeling of the equation. So now for part C. The equation of this has two solutions. Use your graph, the one that you've just drawn, to find two possible values of k. So now you have to be very clear that this is quite a standard question. And when they ask you to solve an equation using a graph, basically notice that the left-hand side is exactly the equation a graph that you've already drawn. And when they say it's equals to k, it really means where does your current graph drawn on the left meet or intersect with another graph k. But what is graph k? It actually just means a graph of y equals to k. So how does y equals to k look like when it's drawn? Very good. It is just a horizontal line. Now bear in mind again that I want two solutions. That means I want two solutions, and that can only happen when the two graphs meet two times or I have two intersections. So when will that happen? When I draw a flat horizontal line that looks something like this as an example, and they meet twice. Right now this line only meets once here, right? That's not enough. Where should I place my horizontal line y equals to k? If I placed it here, would that answer the question? Would I only have two intersections? 1, 2, 3. The answer is no, so that is not the correct location as well. So where would I place it? There's only two possible answers, one here and here. Because in both cases, I will only meet my graph two times and have two solutions. So what is this value of y equals to k? What is the k value? It's basically here. And when does this happen? When the y value is 3.4. I'm referring to the table here as a reference, or below negative 1.4. Can you see that when y is 3.4 or y equals to negative 1.4, I will only meet the graph twice? Yep. So moving on to parts D over here. Let me shift this up a bit. By drawing a suitable line, draw another line. Solve the equation as such. So this is another so-called difficult graph question. But the main thing is that we will still have to rely on our original equation or the graph that we just drawn. And we want to basically actually manipulate this starting equation and do algebraic manipulation to have x cubed over 5 minus 2x plus 1 on one side of the equation. Let's begin. 2x cubed minus 25x plus 20 is 0. I'll first target the x cubed term. Currently it has a coefficient of 2 and I want x cubed over 5. So I have to actually divide by 10 throughout to create x cubed over 5. And I divide by 10 throughout for the rest as well. I'll have 2.5x, and I'll have 2 equals to 0. Okay, so first term, very similar to our graph already, the x cubed term. Now, I have negative 2.5x now, second one that I want to deal with. But I want negative 2x only. So it's slightly more negative now. I have to add 0.5x on both sides of the equation. Okay, once I do that, I'll get x cubed over 5 minus 2.0x. Okay, sorry, I shouldn't write 2.0, that's confusing, just 2x, because I've added 0.5x there, and the 0.5x is added to the right hand side as well. Bring down the plus 2. So far, 2 terms, exactly the same as our graph. Last one, 2, but I only want 1. Algebraically, what can I do? Very good, just subtract 1 from both sides, okay? So I will have x cubed over 5 minus 2x plus 1 after the subtraction of 1, and I have to subtract 1 on this side. So now I have completely my graph on the left hand side, and I have another equation on the right hand side, and now I have to draw y equals to 0.5x minus 1. It's a straight line. Using the quickest method possible, draw it and find their intersections to find the solutions to this question. Okay, so go ahead and do that on your own. If not, I will now fast forward and show you the way to do it. Right, so using a table of values as shown, it's a straight line, so you only need 2 points. I draw that line here, so this is y equals to half x, or 0.5x minus 1. You will notice that there are 3 points of intersections, right? 1, 2, and 3. So these will be your solutions to the equation, and reading the values, my solutions will be approximately negative 3.8 for the first one, second one 0.8 here, 0.8, negative 3.8 here, and last one, it's at 3, right? Around 3. Yep, and that's it. So that is how you obtain your solutions to the equation by drawing a straight line on the graph. We are done.